कर लेते हैं, then we'll just move on, ठीक है? तो एक सेकंड है ना, कहाँ है केसी? अच्छा, so we did one type of question of KC which was के you had to find the value of KC, ठीक है? तो for example, let's just अच्छा, you had to find the value of KC. The other type of question was this one कि वो उल्टा होगा, KC would be given and you would be asked to figure out अच्छा, अब other type of question, ठीक है? KC will be given already. इस question में ना the value of KC is provided, ठीक है? So if you have a look, KC कहाँ पे it's given over here कि your value of KC it's 4 at KC is temperature specific, ठीक है? So the value of KC is already given. इधर मैं लिख लेता हूँ इसको. Equation के C2H5OH and there's a ethanoic acid, so that's CH3COOH. अच्छा, reversible. And then there is the ester, which is CH3CO2 C2H5. And then there is H2O. अच्छा, khair, you've got this reaction going on and you've got your initial moles. Initial moles कितने हैं? Initial moles is कि when 1 mole of ethanol and 1 mole of ethanoic acid are allowed to reach equilibrium. So initial moles are कि you've got 1 mole of this and you've got 1 mole of this. ये 0 moles है. He did not add this. ठीक है, 0 moles of this. And there is 0 moles of अच्छा, there is 0 moles of this. So those are your अच्छा, those are your initial moles, ठीक है? अब इस क्वेश्चन में ना you don't know what the equilibrium moles are. He gave you the value of Kc. यहाँ पे लिख देता हूँ, value of Kc is known. And reverse whether you find the equilibrium concentration. अच्छा, so equilibrium moles are not known. So I'm going to say कि I don't know. You started off with 1 mole, so X moles reacted, right? Because I don't know how much reacted. So पीछे कितने, how many moles would be left? 1 minus X. And if X moles of ethanol reacted to 1:1 ethanoic acid, X moles of ethanoic acid would also react. So that means the moles that will be left at equilibrium would be 1 minus X. And it's all 1:1. So if X moles are reacting over here, on the other side, X moles are getting produced. So यहाँ पे X moles would be produced. X moles over here would also be produced. So in your product, you had 0 moles initially. Now you've got an extra X moles getting produced. So your equilibrium moles will be X moles, और इसके क्या होंगे? That's going to be X moles as well. तो ये clear है ना सारों को? You've done questions like this in AS, ठीक है? I mean, this is actually AS. So in this question, you will not be given how many moles reacted. So you're going to take that as X. Your expression for Kc will be product concentration divided by reactant concentration. So it's going to be X times X. So that's X squared. That's the numerator product, and denominator, the reactant, is 1 minus X squared. 1 minus X into 1 minus X. And the value of Kc is known. That's already given. ठीक है, कहाँ पे given है? That's ये highlight किया हुआ है. It's 4. So Kc is already with you. Kc is 4. And you're going to solve for this. So you're going to take under root on both sides. So it's going to become what? X over क्या होगा? 1 minus X. And that's going to be equal to plus minus 2. So एक दफा ना, first time you have to solve for plus 2, then you have to solve for minus 2. So there'll be two things that you'll be doing. So पहले I'm going to solve for plus 2. So it's going to be X is equal to 1 minus X to the other side. So that's going to be 2 minus 2X. You take 2X to the other side. So that's going to be 3X. equals 2, x would be equal to 2 over 3. So that's one value of x. The other one, okay, let's try and figure out the other one. The other one would be that I'm going to solve for minus 2. So it's going to be x over 1 minus x is equal to minus 2. If I take that to the other side, so it's going to be what? Minus 2 and plus 2x. And if I take 2x to the other side, so it's going to be minus x is equal to minus 2. So your x would actually be equal to plus 2. So I'm getting two values of x. The correct value would be the one where your equilibrium moles will be positive. Okay, so you're going to reject one of them. Consequently, which one should I reject?
Plus 2.
Plus 2.
Okay, if you use plus 2, though, your equilibrium moles will come out to be 1 minus 2. That's minus 1. Moles are never negative. Okay, so we're going to reject this one. Okay, so I'm going to reject this one. Or reason भी लिख देता हूँ कि moles cannot be. X can be anything. Your equilibrium moles cannot be negative. So your equilibrium moles cannot be. They can simply not be negative. Okay. So बस ये KC you got. Remember KC you got two questions. One is either थोड़ा सा line draw कर लो just. अच्छा, so again, one is K. You would be given equilibrium moles. You would be told how many reacting out and how many are getting produced, and you'll find the equilibrium concentration. Then you're going to plug it in the expression, and you'll find your Kc value. Okay, that's one question. The other one is the exact opposite. Okay, and इसमें Kc का we did talk about Kc. Just remember, everything is written over here. So I'll just do just a couple of more questions, and then we'll just move on. ये वाला कर लेते हैं quickly. You've got in this case, what do you have? You've got 1 mole of silver ions and 1 mole of Fe2 plus ions. So 1 mole of this and 1 mole of this are added. And when equilibrium was established, so initially there is no silver and there is no Fe3 plus. Okay, remember silver nitrate has silver plus 1, FeSO4 has Fe2 plus. Okay, so these two are added. Once equilibrium was reached, it was found that there's only 0.44 moles of silver ions. So there's 0.44. You start off with 1 mole, but now you've got 0.44. So that means what? It means that 0.56 must have reacted, right? So 0.56 must have reacted, and it's 1:1. So 0.56 of Fe2 plus would also be gone. And if 0.56 react with 0.56, so आगे जाके they're going to produce 0.56. It's all 1:1. So 0.56 are going to get produced. And यहाँ पे भी ना 0.56 are going to get produced. So your equilibrium moles will be 0.44, 0.56, and 0.56. ये clear है सारों को? Is this question clear?
Yes, sir. Yes, sir.
Yes, sir.
So बाकी है कि you'll write the expression for Kc. So Kc will be 0.56 divided by 0.44 times 0.44. Okay, remember you don't use moles, you use concentration, but the container volume is 1 dm cube, so the concentration is moles over volume, which is going to be exactly the same. Okay. I did not write numerator में ना I did not write this, ठीक है, because silver was a solid. You don't write solid concentration. You take solid concentration to be 1 or constant, so you don't write that, ठीक है. So that's going to be, पता नहीं क्या, what do you get for this?
$2.89.
ठीक है, 2.89. Just remember कि solid concentration is taken as 1, ठीक है. So no matter what the moles are, Kc expression uses concentration. ठीक है, that's taken as 1. So ठीक है, let's just switch to Kp now. I said, remember, A2 के अंदर ना, you're going to get Kc questions as well, you're going to get Kp questions as well. Just remember that A2 equilibria is not going to be focused on AS, but you might get the same type of questions that you got in AS as well. अच्छा, अब ये कि what's Kp? Kp is basically the same thing, except the only thing is that it uses pressure. It's for gases. Okay, so the only difference is पहले तो ये कि pressure and concentration are directly proportional for gases. Only gases. Any other state is going to be taken as 1 or constant. ठीक है, its pressure would be taken as 1 or a constant. So pressure is equal to concentration for gases only. ठीक है, gases are the only thing that exert pressure equally in all directions. ठीक है, so that they're the only thing where measuring pressure makes sense. ठीक है, solid के लिए, I mean solid ऊपर की तरफ, it's not exerting pressure upwards, right? So solid will not be exerting pressure equally on all sides. Gases will be equally exerting pressure on all sides. So Kp is only for gases, and you've got exactly the same expression, except that you'll be using partial pressures. See, I'm going to come. So the difference here होगा कि previously Kc was what? Kc was concentration. It was concentration of NH3, that squared, and everything divided by the concentration of N2 times concentration of H2 cubed, right? So Kp is going to be exactly the same, except you'll be using the pressure that's exerted by NH3, that squared. So that's partial pressure of NH3, ठीक है, divided by the partial pressure of N2 times the partial pressure of H2, and that's going to be cubed. So that's what Kp is. और इसका unit भी इसी तरह, the unit for Kp could be I mean, it could be unit for pressure is, you don't need to change the unit. Just remember, the unit for pressure could be anything. It could be atmospheres. They could be talking about atmospheres. They could be talking about it in pascals, or they could be talking in kilopascals. You don't need to convert it. So again, if the pressures are given in atmospheres, so it's going to be atmosphere squared divided by atmosphere time atmosphere cubed, right? So that's going to give you what? ATM minus 2. Similarly, the same thing could be in kilopascals. So just don't convert it. Okay? Just use kilopascals, and your unit is going to come out to be in. It's going to come out to be in kilopascals. Okay? So this is Kp. The only extra thing about Kp is that you would have to calculate partial pressure. Otherwise, everything is exactly the same. So Kp के question एक दो निकाल लेते हैं. So let's say ये कर लेते हैं. Sulfur dioxide. So this is the reaction that's this is the reaction that's going on. Now the first part would be exactly the same initial moles, okay? As initial moles here, there's 2 moles of sulfur dioxide that's added, okay? So you got 2 moles. And there's 2 moles of O2 that's added, so there's 2 moles. And they're left to reach equilibrium, okay? So that means there's no SO3 to begin with, okay? Then you have your equilibrium situation. Okay, what's left at equilibrium? So at equilibrium, the pressure is described, and he's told us that at equilibrium, you got 1.8 moles of sulfur trioxide. So at equilibrium, you've got 1.80 moles of sulfur trioxide. That is the information that's provided, okay? So that means, so you started off with 0 moles, you've got 1.8, so that means 1.8 got produced, right? Now, according to the ratio, if you want to produce 2, it's 2:2, right? So if you want to produce 1.8, so yahan pe 1.8 must have reacted, right? And it's 2:1. So to produce 1.9, half of that must have reacted. So that's 0. Okay, so if the amount of moles is increasing on the other side, the amount of moles on the other side would be decreasing. So you start off with 2, 1.8 have reacted. So that means you're left with 0.2 moles. And O2 you started off with 2 moles and now 0.9 have reacted. So that means you're left with 1. So ye clear hai? Is this clear?
Yes, sir.
Yes, sir.
सारों को clear है? तो
Yes, sir.
अच्छा. अब इससे आगे, moving on. Now the only difference between KC and KP is there's an extra step where you have to calculate partial pressure. That extra step is that these are your moles at equilibrium. Now, together, all these moles together, they exert a pressure of 2 times 10 to the power 5 pascals. They told us. So it's the combined pressure of all these. So you have to find, what is the pressure that's exerted by individual gases? So you would have to find the partial pressure. Partial pressure, the formula of partial pressure is if I start off with the partial pressure of SO2, so it's basically the mole fraction or the percentage. I mean, all these gases combine equilibrium wale, they're exerting this pressure. So I need to find out what contribution does SO2 have. So it's the mole fraction, or you can say percentage of SO2 that's at equilibrium multiplied by the total pressure. So in this case, it's going to be 0.2 moles out of 0.2 moles out of what's the total moles present at equilibrium? That's what's 0.2, 1.1?
3.1.
3.1. Achha, so times 2 times 10 power 5, right? So that's my partial pressure of SO2. And I'm going to do the same for O2. So that's going to be mole fraction. That's 1.1 divided by 3.1 times 2 times 10 power 5. Okay, so that's your pressure that's exerted by O2, and then you have SO3, which is 1.8. So 1.8 divided by. So बस ये सारे pressures आ गए, and you're going to use the same KP expression. So I'm going to just plug it in. It's PSO3 squared, or divided by as a PSO3 squared divided by PSO2 squared times क्या PO2. So what I can actually do is I can kind of simplify things a bit. के बजाय इसके कि I put in everything in the calculator, what I can do is it's basically SO3 here, that's 1.8, or bottom pick here, that's, I say 1.8 squared. Yeah, the calculator can just put everything in calculator and find this out. So it's 1.8 squared. नीचे का SO2 is sorry, SO2 is 0.2 squared times O2, that's 1.1. अब बाकी चीज थोड़ी simplify कर लो. What would you get? It's 2 times 10 power 5, 2 times 10 power 5. I think bottom के ऊपर you're going to get 2 times 10 power 5. And एक 2 times 10 power 5. 3.1 जो है, that's also going to get cancelled out. So you'll be left with 3.1 over here. What 3.1 would come upwards. So anyways, you can just plug in everything in the calculator and find out what the value is. क्या आ रही है वैसे इसकी? Just remember, I'm just simplifying and then adding. Okay, you can just do it in one step. So क्या है? What answer did you get?
So 1.14 times 10 power negative 3.
कितना? 1.14 times
10 power negative 3.
negative,
3.
and it was question में क्या था? It was pascals, right? So it's going to be pascals minus 1. ठीक है. I'm not really sure if that's the answer, लेकिन मतलब math देख लेना, ठीक है? Otherwise, everything looks fine.
Sir, if you solve all of them like separately and then put it in the equation, it's going to be the same, right?
हाँ, मतलब मैंने तो simplify कर लिया ना. मैंने तो math की तरह I just simplified it. क्योंकि it's 2 times 10 power 5 squared, 2 times 10 power 5 squared at the bottom, and then there's 2 times 10 power 5 with O2 as well. So that 2 times 10 power 5 would get cancelled out. You'll be just left with 2 times 10 power 5, right? So I just simplified it, and then hopefully you should get the same answer. I can check the answer के ये कौन से पेज पे था? Page 7, एक second. Can I page ठीक है. So it's अच्छा, यहाँ पे it's 1.12 times 10 power minus 3. What did we get? But we're getting almost the same, 1.14. Well, I think the only problem is if you solve this first and you don't do it in one go, there's a problem which is a rounding error. Okay, if you do it like this, you solve this, so you're obviously rounding this value. Okay, you solve this, you've rounded this value. You've solved this, you've rounded this value. Then you plug it in. So most likely you're rounding it so many times that your answer will not be that accurate. Okay, so 1.12 is probably going to be less accurate. Whereas if you solve this in one go, then your answer would probably be more accurate, okay? Because you didn't there's lesser rounding error, okay? Today clear है?
Yes, sir.
Yes, sir.
Achha, anyway, so that's achha, remember iske andar na KP ke andar there's another thing which is that you don't even need moles, right? You just need the mole fraction or the percentage of whatever gas you've got, okay? So you can even work with kidhar hai worksheet? So you can even work with percentage, okay? Start mein there would be questions where you could just solve everything using percentage. Just 1 second, let me find that out. That's a pretty question, huh? Just saying 20% steam getting dissociated, right? So they've told us 20%. So remember, you don't even need to know the actual moles. So for example, if I start off at 10 moles of steam, he's just told me 20% dissociated. So that means if you start off at 10, so 20% is gone. So that means you're left with, what is 20% of 10? That's 2 moles. So that means you're left with 8 moles, right? So 20% of it dissociated. So that means 2 moles are gone. And 2 moles, if they react, they would produce 2 moles of H2. Or 2 moles if they react, they're going to produce 2:1. So they're going to produce 1 mole of O2, okay? So remember, moles are kind of irrelevant in KP. If you know what is the ratio or percentage of each gas, even that would work, okay? So 10 moles is start here, 20%. 10 moles is just an arbitrary number. You could use any number. You'll get the same ratio. So 20% dissociated. So that means 2 moles are gone. 2 moles will produce 2 moles of this and 1 mole of this, okay? And 2 moles are gone, so you're left with 8 moles, okay? So your KP value would be, iska partial pressure kya hoga? That's going to be 8 divided by 11. 11 is the total. So it's going to be 8 divided by 11 times 1 atmosphere. That's the total pressure. So 8 divided by 11, so D is going to be the answer. 2 divided by 11, okay, 2 moles divided by the total moles, that's 11 times 1. Okay, that's 2 divided by 11 is this thing. Or ye 1 divided by 11. So that's probably going to be this 1 into 1. So ye be clear that KP does not need the actual moles. Even if you know the percentage, that could work as well. Okay? Clear?
Yes, sir.
Yeah.
Okay.
So, or in addition to that, remember one thing, both KP and KC, if they don't have any units, in that case, you don't even need to do the whole working. Because just say 2 times 10 power 5 almost got cancelled out, right? The reason it did not get cancelled out was because the denominator terms were greater in number. So that's why 2 times 10 power 5 did not get cancelled out, okay? But if the number of terms are equal in the numerator and denominator, that means if the equation had equal number of moles on both sides, so then what would happen is that ye wala jo part hai na, divide by 2 times 10 power 5 divided by 3.1, everything, the whole working, the whole calculation of calculating partial pressure, that would be completely irrelevant because that entire calculation would get cancelled out in the expression. So if only in this case if Kp has no units. So if Kp has no units, then no need. So then no need to calculate partial pressure, use moles directly. तो ये भी clear है कि Kc के अंदर भी you don't need to calculate concentration. If Kc has no units, तो वो जो working है ना, that will automatically get cancelled out in the expression. Is that clear?
Yes, sir.
तो मैंने clear है ना सारों को कि equal moles होते हैं ना, top in equal terms होती है, the whole 2 times 10 power 5 3.1 part, that would all get cancelled out. अच्छा, अब so we are done with AS equilibrium, right? तो अब आ जाओ, let's start with, थोड़ा सा time है, so we'll just start with very basic A2 equilibrium, which is going to be a continuation of what we just did. Starting with, थोड़ा सा start करने के लिए ना, I would have to start with acids and bases, ठीक है? Now that's going to be our first application of equilibrium, ठीक है? In acids and bases. Acids and bases are equilibrium systems. So what's an acid? It's a proton donor. Acha, what's a base? It's a proton acceptor. What's a proton? It's an H+1 ion. So basically, you've got a molecule that it could be any molecule, ठीक है? So you've got two molecules. One of them is a base, the other one is an acid. So an acid would be releasing H+1 ions. और जो base है ना, that will be accepting H+1 ions. Acha, so basically, acha, why is it important? It's important because all reactions on this planet, they happen in water, ठीक है? Water is everywhere. Planet Earth की chemistry ना, that's got a lot to do with water. Water is everywhere, ठीक है? It's inside our cells, it's inside our bodies. We have to drink water all the time. Plants need water. So chemistry of life, ठीक है? Wherever there is no water, there's no chemistry happening. What do we do with water? What does our body do with water? It absolutely does nothing, ठीक है? It does not break it down. I mean, शायद it might break it down slightly, but most of the time, we just consume a lot of water, ठीक है? And it's gone, ठीक है? We sweat it out, ठीक है? So we don't, I mean, our body basically doesn't do anything with water. Doesn't break the bonds, doesn't do anything. Water is only a medium for reactions to happen, ठीक है? The water is just a solvent. Water is the primary solvent on this planet, ठीक है? 70% of everything is water. Or water help क्यों करता है? Because particles would not be able to move around if there was no water. So water is basically the medium in which these particles are floating around. ठीक है? Oxygen, if I breathe in oxygen, how does it get to my cells? Okay, it floats around in water and water takes it. I mean, basically blood takes it. ठीक है? Blood is water and takes it everywhere. It distributes it. So water is not doing anything except it's a medium through which everything is happening. And particles would be able to move around, collide, and they would react with each other. If particles are not able to move, they are not able to collide, nothing would happen, ठीक है? The moment water is gone, ठीक है, even desert के अंदर all chemistry stops. Why isn't anything happening on the moon? Because particles cannot move around because there is no water. So anyway, so water is important and it's everywhere. And the other point is that water is not just water. Okay? Water is like if this medium is H2O, so there's going to be a lot of H2O molecules. But it's not just going to be H2O. Some of the water molecules, they tend to ionize. And during collision, some of these water molecules, they break down and they produce two ions. One is H+1, the other one is OH-1. Okay? So some of these water molecules are going to, some of them are going to break down and they're going to produce H+1 ions and they're going to produce OH ions. So H+1 and OH ions. So water is water, but there's some H+1 and OH ions. And the thing is, in a neutral solution, H+1 or OH ions, they would be present in equal concentration. Okay, if water breaks down, it's going to produce one H+1, one OH ion. So it's going to be produced in equal amounts, right? So that's known as a neutral solution. Okay, that's known as a neutral solution. That's known as pH 7. Okay. But sometimes what happens is that you add a molecule that is acidic. So sometimes what happens is, let's say you add a molecule that's acidic, so that molecule starts releasing H+1 ions. So pani mein kya hoga? The amount of H+1 ions will increase. If you add an acid to it, the amount of H+1 ions would increase. They would become greater than OH ions, and that would be known as an acidic solution. And you're going to say that the pH is now less than 70. Okay? And vice versa, sometimes what will happen is that you would add a molecule of a base. What does a base do? It removes or accepts H+1 ions. It does exactly the opposite. So the quantity of H+1 ions will decrease. Or the quantity of OH ions will relatively increase. And you're going to say that the solution is now basic or alkaline and the pH is now greater than, it's greater than 70. Okay? So, ab ye ke water is an equilibrium reaction. Okay? So we're going to discuss it's an equilibrium reaction. But remember this, for reactions, every reaction on this planet is very sensitive to the pH. Okay, what type of water do you have? Okay? Some reactions prefer that there are equal number of H+1 and OH ions. Some reactions, like your digestive reactions, they prefer that there is more H+1 ions. Maybe the reaction need H+1 ions. Then there are other reactions that prefer that the solution is more alkaline. There are more OH ions. Okay? So every reaction, because they're happening in water, they have a particular preference. And so if some reaction needs H+1 ions, those reactions will happen optimally at a pH that is acidic, and so on. Okay? So reactions are very sensitive to what type of solution you have. Is clear, Sarah? Is this clear?
Yes.
तो चलो ठीक है, कल कंटिन्यू करते हैं. We'll talk about an equilibrium constant that is linked with this thing. ठीक है, तो कल फिर ना we'll talk about how to deal with this equilibrium. ठीक है, तो चलो ठीक है. Okay everyone.
Thank you, Hafiz.
Hafiz.